All right, so we're going to talk about solving quadratics algebraically. And so the reason that we bring this up is a lot of you guys will solve quadratics by like the quadratic formula, which is nice. And some of you will solve by factoring, which is great. But a lot of quadratic problems, the way that they're set up, lend themselves really easy to just basic algebra. Like, remember the good old days when we just solved stuff like 2x minus 1 equals 5? Right? You just add 1 to both sides, and then you get 2x equals 6, and you divide by 2. You get x equals 3. That's what I'm going to recommend you do on some of these quadratics that we have. They're set up so that you can just solve them algebraically. You don't have to worry about throwing a ton of things into a formula or trying to factor. So let's look at this one. So you've got 3 times x minus 2 squared is equal to 12. And what we can do on these is if you kind of think of the whole x minus 2 squared thing as its own entity. So in other words, what I'm saying is let's pretend that we basically have 3 red triangles, where the red triangle here is just standing for the x minus 2 squared. If you can get this entire thing, which I'm going to now call red triangle, by itself, it's pretty easy to solve for the red triangle once we, change it back to x minus 2 squared. So if you had 3 red triangle equals 12, this would be pretty easy. You just divide by 3 on both sides. So that's how we're going to approach problems like this. We're just going to get the x minus 2 squared part all by itself. So we're going to divide by 3 on both sides. And when we do that, we're going to get x minus 2 squared is equal to 4, because the 3's will get rid of each other. Okay, at this point, now the question is, what do we do to solve? So if you have something squared and it equals 4, what you can do is you can apply the square root to both sides. And you'll get plus or minus over here on the right. Don't forget that, by the way. That is like the #1 mistake people make. Okay, so we'll scroll down here. And when we solve this, if you take the square root of something squared, I just want you to think about this for a second. Like, if you have 6 times 6, and you take the square root of that, wouldn't that just be 6? Because the square root of a number, right, so the square root of 36 is asking what number multiplied by itself would give you 36. That's what it's asking. So if you've got the square root of 6 times itself, then the answer would just be 6. So this is kind of nice. The square root function serves as the inverse function for the squaring, which is why we're taking the square root. We're taking the square root here to get rid of the square. So what we're left with on the left side is just x minus 2. On the right side, we're left with either plus or minus the square root of 4. Can we just say the square root of 4 is 2? Let's do that. This plus or minus is a little confusing, but all we're doing basically is saying, hey, if you take the square root of 4, to be fair, it could have been 2 or negative 2, right? Because negative 2 squared would give you 4. Also, positive 2 squared gives you 4. So we're not sure which one it was, so we put plus or minus just to indicate it may be positive 2 or negative 2. And we'll just leave the plus or minus there. Okay, so now we've got basically x minus 2 is equal to plus or minus 2. And we're just going to solve like normal. It feels a little weird to keep that plus or minus 2 there, but we'll do it. So we're going to add 2 to both sides. And this is really important. You can't add plus or minus 2 with positive 2. So what you do, the correct way to do this, is to say that x equals, those go away, x is equal to plus or minus 2 plus 2. Now, if you'd like to break this up into 2 separate cases, you can do that. And so what you'll get is, on the one hand, you'll get positive 2 plus 2. On the other hand, you'll get negative 2 plus 2. And then we can just write these down. So positive 2 plus 2 is 4. Negative 2 plus 2 is 0. So our 2 solutions then are just going to be x is equal to 0 and 4. And if you want, you can go back to the original function and plug those in and make sure they work. Okay, so if we go back up, if you plugged in 0 here, you would do 3 times 0 minus 2 squared. 0 minus 2 is negative 2 squared is 4. 3 times 4 is 12. So that works. If you go back and you plug in 4, you would get 3 times 4 minus 2 squared. 4 minus 2 is 2. If you square that, you get 4. 3 times 4 is 12. So that works. Okay, let's look at another example here. So we have negative 4x squared plus 1 is equal to negative 35. And so what I'm going to do here is, on the last example, we tried to get the x minus 2 squared by itself. Really, if you can isolate the part where the x is getting squared by itself, then you'll be able to solve. So, first thing I would do here is kind of pretend that the x squared is like our red triangle of sorts. So, if I have negative 4 times red triangle plus 1 was equal to negative 35, and I'm just trying to get the red triangle by itself, I would subtract 1 first, and then I would divide by negative 4, and that's exactly how we're going to approach this problem. So, let's do that. Let's subtract 1 from both sides. When we do that, we get negative 4x squared. Those get rid of each other, is equal to negative 36. And then from here, I'm trying to get that x squared by itself. I'm going to divide by negative 4. I'm not subtracting 4 here. I'm dividing by negative 4. So now I'm going to have x squared is equal to negative 36 divided by negative 4 is the same thing as 36 divided by 4, which is 9. Okay, now that I'm here, I can take the square root of both sides. Don't forget the plus or minus. People always forget that. When you take the square root of x squared, the square root part and the square part are inverse operations of each other. They get rid of each other, essentially. So you're going to be left with x is equal to plus or minus, what's the square root of 9? Well, it's 3. And so your answer here, some people will actually leave that as the answer. That's fine. I kind of like to write them out separately. So x is either going to be 3 or negative 3. Either one would work here. All right, let's look at another one. So x minus 1 squared over 3 plus 4 is equal to 31, and they want us to solve for x. So again, we're just going to treat this x minus 1 squared like it was its own little variable, and we're going to try to get that by itself. So the best way to do that, there are a couple ways you could go about this. It doesn't really matter. Some people would multiply by 3 here to start to get rid of the 3 on the bottom here. You can do that. I personally like to subtract 4 first and then multiply by 3. Because if you multiply everything by 3, this gets multiplied by 3, which would cancel the 3. This gets multiplied by 3, which would make it 12. This gets multiplied by 3, which would make it 91. Then we'd have to subtract 12. You can do that. That's fine. Personally, I'm going to subtract 4. So subtract 4 from both sides to start. By the way, you cannot square root this to start. If you square root this, you're going to get you would get the square root of x minus 1 squared over 3 plus 4, which unfortunately does not just cancel the square root there. It doesn't just turn into x minus 1 over 3 plus 4. That is not correct. Gosh, don't do that, please. Okay. So yeah, don't do that. I'm erasing it. That never happened because people don't do that. Okay. So this will be x minus 1 squared over 3 is equal to 27. Now from here, this is where I would multiply by 3. And when you do that, you would get the 3's cancel. You'll get x minus 1 squared is equal to 27 times 3 is 81. From this point, a lot of people want to add 1, but you can't add 1 because the 1 is inside the parentheses there. It would not help. So you're going to want to take the square root of both sides here. So we will apply the square root of both sides. Don't forget the plus or minus over here. By the way, whenever you apply the square root, you have to do plus or minus. If you just come across something that's like the square root of 9 and you haven't actually put the square root in there, we're just assuming that that's the positive version. If it's minus the square root of 9, obviously it's the negative version, but you don't need to assume plus or minus if you just see the square root. If you take the square root, which is what we're doing here, we're applying the square root. It was not there before, but I wrote it in here, the blue. You have to do plus or minus. I was always so confused by that when I was in high school. So what you're left with on the left side here is just x minus 1. And on the right side, you're left with plus or minus. The square root of 81 is just 9, so I'll just write 9 there. And from here, we can add 1 to both sides. So let's scroll down a little bit here. So we'll add 1 to both sides, add 1 to both sides. And so this will give us x is equal to plus or minus 9 plus 1. And by the way, please don't just add 1 and say, oh, it's plus or minus 10. That does not work. All right, so our two solutions then are positive 9 plus 1 and negative 9 plus 1. So positive 9 plus 1 is 10. Negative 9 plus 1 is negative 8. So our two solutions then are x is equal to negative 8 and positive 10. Ooh, that was a terrible bracket. Let's try that again. There we go, much better. All right, let's look at a couple more. So this one you got 2/3 times x plus 1 squared minus 6 is equal to 18. And the goal here is to kind of get this x plus 1 squared by itself as if it were the variable. So in order to do that, first I would add 6. Again, you could multiply by 3 here to get rid of this fraction, but that would have to get multiplied by 3 too. So I just find it slightly easier to add 6 to both sides to start problems like these. So we'll have 2/3 x plus 1 squared is equal to 24. And now we've got this fraction here, so I want to get rid of this fraction. Personally, what I like to do on these is I will not only multiply by 3, but I will also divide by 2 in the exact same step. This is called multiplying by the reciprocal. So you have a fraction here, 2/3. If you flip the fraction and just change the top and the bottom, you'll get 3/2. And what's nice about this is when you multiply this, on the top you get 6, and on the bottom you get 6. And 6/6 is just 1. So it's kind of like we don't even need 6/6. We can just write x plus 1 squared here because you have 6/6, but that's just 1. So we don't really need to write 6/6. So in other words, basically the 3/2 and the 2/3 cancel each other. So all right, that's going to be equal to 24 times 3/2, which is 24 times 3 is 72/2 is 36. From here, we're going to apply the square root because I want to get rid of that square. Don't forget plus or minus. Please, by the way, do not subtract 1 here. You can't do that yet. You have to apply the square root. So on the left side, we're just going to have x plus 1. And on the right side, we're going to have plus or minus the square root of 36. And then we can subtract 1 from both sides. So we will have x is equal to, oh, by the way, so plus or minus 36 is the square root of 36 is plus or minus 6, and then you subtract 1. So our two cases in this scenario would be positive 6 minus 1 and negative 6 minus 1. So this would be 5. This one would be negative 7. So our two solutions are going to be x is equal to 5. Well, let's do negative 7 first. Negative 7 or 5. All right. I think we got 2 more to look at. All right, so I've included this one here because this one doesn't work out nicely. Like we get a radical that's a little ugly. So I probably should have done an example like this earlier, but here we are. So, all right, on this one, we want to get the x minus 1 squared by itself. So I would first subtract 8. If you'd like to divide absolutely everything by 2, you could technically do that. But I'm going to subtract 8. So now we have 2x minus 1 squared is equal to 48. And I'm going to divide by 2 here. So that would give us x minus 1 squared is equal to 24. And we're going to apply the square root on both sides. So we'll get plus or minus there on the right. So we're left on the left side with x minus 1, and that's equal to plus or minus the square root of 24. And this is where it starts to get a little messy because the square root of 24 is not like a whole number, right? There's no whole number that if you multiply it by itself, it'd give you 24. So what we're going to do is we're going to actually simplify the square root of 24. I'm assuming that you know how to simplify a radical expression. If you don't, I actually have a video on simplifying radical expressions. You can just look it up. So 24, I'm just going to run through this real quick. That breaks down into 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So x minus 1 is equal to plus or minus. The square root of 24 is really 2 times 2 times 2 times 3. There is a pair of 2's here, so that'll become a 2 on the outside. So you'll be left with 2 times the square root of 6 there. So this is going to be plus or minus 2 times the square root of 6. From here, we will solve for x. So we'll add 1 to both sides. And we'll be left with x is equal to plus or minus 2 radical 6 plus 1. And honestly, if you'd like, you can just write this as your solution. There's no need to write, okay, you could theoretically write x is equal to negative 2 radical 6 plus 1, or positive 2 radical 6 plus 1, and then you could throw that in parentheses. But most people are totally happy with that form right there. So we'll just leave it like that in the box there. Okay, I got one last example for you. Okay, so these, again, by all means, you could do quadratic formula. You could probably solve this by factoring. But what's nice about these is let's distribute both of these. So let's do the 2 times the x squared and 2 times negative 3, and we'll do the 3 times the x squared and 3 times 1. Let's see if we can just get this to work algebraically. So 2x squared minus 6 is equal to 3x squared plus 3. And notice how there are no x terms here. There are x squared terms. There are numbers, but there are no x terms. In a typical quadratic, we're used to kind of like 3x squared plus 5x plus 7, and we're used to having this x term. But the good news is, if there's no x term in there, a lot of times if you just have 3x squared plus 7, you can solve these algebraically. So I guess that's my tip for you guys, is if you don't see an x term and you just see x squareds and you just see numbers, then you could probably do this algebraically. So I like to keep my variables positive, so I'm going to subtract 2x squared here. If you subtract 3x squared to get the x squareds on the left, that's fine. You'll just have a negative x squared. I prefer having positive x squareds. Okay, so from here we've got x squared is equal to, x squared plus 3 is equal to negative 6, so I'm going to subtract 3 from both sides, and we're left with x squared is equal to negative 9. Okay, so to solve for x here, we would take the square root of both sides. Don't forget the plus or minus. But at this point, I'm a little worried. We've got a problem. And that is that we're trying to take the square root of negative 9. And this is literally the next lesson. What we're going to be talking about is how to take the square root of negative numbers like this. The problem here is that there's no real number. There's no like whole number or negative, integer, negative whole number, or really any number, even decimals or fractions, where if you multiplied it by itself, it would give you negative 9. Some people are like, well, what about negative 3? Well, think about it. Negative 3 times negative 3 gives you positive 9. And 3 times 3 gives you positive 9. So there's no way to multiply a number by itself to get negative 9, right? So, I mean, you can try this. You can throw this into your calculator and say, hey, what's the square root of negative 9? Or what's the negative square root of negative 9? But it's just going to say something to the effect of error. Why do you hate me? Why do you make me do stuff like this? I can't do this. And so on this one, there are actually no solutions. There are no numbers that we could possibly plug in up here for x that would ever make this work. So if you ever try to get the square root of a negative number, there are no real solutions, okay? So we'll talk about imaginary and complex solutions in a little bit, but there are no real solutions for this problem. Also, I noticed that I labeled this problem number 5, but there was already a number 5, so I just changed it and called it number 6. All right, we're all done.